has opened the door on a tiny, extremely tiny timescale. Argued that this world cannot be seen. Thanks to, and we divide it again by 1,000. Divide it again by 1,000. Divide it again by 1,000. And again by 1,000.
The Royal Swedish Academy of Sciences has decided to award the 2023 Nobel Prize in Physics in equal shares to Pierre Agostini, the Ohio State University, U.S.A., Ferenc Krausz, Max Planck Institute for Quantum Optik, Garching, and Ludwig Maximilians Universität München, Germany, and L'Huillier, Lund University, Sweden, for experimental methods that generate attosecond pulses of light for the study of electron dynamics in matter.
Both of pulse trains and of isolated individual pulses to be used for fundamental research, but also future applications.
Thank you, Professor Olsson. Now, Professor Mats Larsson will give a more detailed presentation.
And let me remind you, electrons are not only working in gadgets like this. They are working in your full body. Chemical reactions are controlled by electrons, and they move on a time scale of attoseconds. 4 experimental methods that generate attosecond pulses of light for the study of electron dynamics in materials.
I was teaching, so yes. So I picked the phone when I guess you ring the 3rd time or 4th time during the pause. And then the last half hour of my lecture was a bit difficult to do, but yes.
Yeah, it was fascinating. We had a lot of information to provide you with, Professor.
I think this is a typical example of research which is very fundamental. We have been working in this field during 30 years. Only now you begin to have application in sight. So basic research is really important and has to be funded by different institutions or agencies because it takes time.
We hope to see you again tomorrow when we will announce the Nobel Prize in Chemistry.
So this is, I would say, a major breakthrough in fundamental physics, our sort of fundamental understanding of the universe. We can now look into atoms and see how electrons are moving. This year's laureates have developed a way to take pictures, if you like, of the motion of electrons inside materials. And in order to do this, they needed to create extremely short flashes of light to illuminate those electrons. So there are as many attoseconds in a second as there are seconds which have passed since the Big Bang, 13.8 billion years ago. So it's an extremely short period of time. And by using this new technique, we can, for example, probe how charge migrates inside atoms and molecules, how electrons move, giving rise perhaps to new electronics. And we can also probe molecules in new ways, which maybe will lead to new medical diagnostic techniques.